This is the test mule that I've been running for the last few weeks on some new developments, and I'm at the point of retiring the test mule in favor of a more production ready replacement. So test mule 1 will be dismantled, and I thought I'd walk you through what we had and what we achieved before I did so. First, we went back to testing using the reverse and boiler type chassis, where there is no smoke gear, no smoke boss, no means to run smoke. I made an adapter some years ago, and we reused that. We've got a fan-driven smoke assembly that is designed specifically for American Flyer steam engines, S-gauge. We have a board that I built breadboards for several years, and Andy has come up with a PC board design that we can actually get manufactured, and it works beautifully, so that we can control the heat and the smoke through a thermistor and a voltage regulator in the smoke. So it's a very smart smoke system. We've got some heat sinks in the test process. We will design some of this out. There is a puffer board that runs the fan down here so that it's synchronized and timed to the stroke and to the sounds of a chuff board. This board makes the chuff sound out through what they call a sugar cube speaker, and they share grounds and some other wiring things that makes it a little messy, but because we don't have this gear, we didn't have a means to send out a trigger for when we wanted to see the chuff. So we've created some attachments, some spacers, a shaft, a gear, a worm, and we're using fingers with some metal stripes on this gear to trigger when it rotates. Here we're getting 2 chuffs per revolution, and it sends out a puff of smoke and a sound of a chuff for those 2 revolutions. We're using a DC can in this particular configuration, but I do believe we'll be going back to the wired field, but we will configure that motor to run on DC. So we'll still use DC power to that motor, but it will be a vintage American Flyer motor running on DC. I ran out of metal links, so I actually printed some, and I put them on this train, and they actually worked. They held up and did the job. It was pretty rewarding. We then worked on the tender. We had some ideas on the pickups for the tenders, so we've created all-wheel pickup that have some bit of a suspension. They articulate in the center, and every wheel is picking up power and sending it up to the above board of the tender for the controls. This is a standard chassis with an adapter for all of the PC products, and what you can see here is I've designed the chassis as one piece now, and everything fits on that. The wheels and the electronics all fit onto it, so it's going to be, we won't have the blue and yellow tie wraps holding this thing together. So that's better. We're still using the 0103. We have a variation of this coming from our Andy again, which is a little more robust with some updated components, but it will still run AC in and DC out. We use the rectifier still to get the AC to DC, and the DC feeds into these 2 boost buck boards. They regulate voltage for the boards here and for the smoke. There'll be a separate miniature 5-volt regulator that we'll be adding to the new assembly that will feed speaker boards that will be fitting underneath here, and I have them mounted in this particular model. That's the speaker board, and that's the amplifier, and this is the radio control, and you'll be allowed 4 buttons of sound, and we'll use a device like this with the 4 buttons, and anticipation to have a steam whistle, a bell, crew chat, and a station announcement programmed into the soundboard, and a radio signal goes through the receiver to a relay to the soundboard and then out to the amplifier, and inside here will be a speaker. There's the speaker inside here. So this is the Tinder adapter chassis concept, and that's going to be, it is now refined. We'll be decommissioning these parts and putting them on real boards. I'm going to set this down and show you the notion of the all-wheel pickup, if I can. Barely, yes, okay. Here you'll see a wire coming through here, and a wire, a connecting wire going up through the chassis, and at every wheel then the axle is rubbing on that wire. We may change that design. We have some refinements we're working on, but in general that's how it's going to work, so that all the wheels will pick up energy and bring it to the controls. And don't worry, I've got a better approach to this than some old erector set. We've got that figured out. In any case, this is the, since I didn't have a body on here, I had to add a few weights, so I put some wheel weights in the front. It's like we did on the old farm tractor back in the day. So we'll be working on some modifications and changes to this as we go forward. I just thought I'd show you this before I disassemble it and retire it. It has worked wonderfully. It actually went backwards and forwards multiple times. It even made a few loops. Of course, wiring was a little in trouble a few times, but it's held up, it's worked out. And with those experiments, we now have this refinement, and I'll be working to wire this up with some harnesses so we don't see wires flailing all over the place. Same trucks with pickup, same smoke. I don't know what other changes there would be, but I'll just show you this. It's always an experiment when you do this without practicing, or at least testing, but I have. Okay, there we go. Those wires will be hidden inside, but as you can see, it's a one piece. It fits nice, it looks good, and that's been proven and tested, and we're ready to go. I had an engine, thought I'd show you, but I must have drug it off, put it somewhere else. We had some changes to the sensor devices. Oh, I know where they are. I'll be right back. I'll just bring you with me so you can see the other half here. Yeah, well, I'll show you. This is not exactly the most perfect example, but it's sort of what's happening. I've been testing out an idea from Andy and I, where we end up, instead of using the gear and fingers, we now, in this case, we have the boss for the smoke gear. So we're gonna make our own gear. Looks like this, and it will have some cams, and it will hit a switch, and that switch will trigger the puff and chuff gizmos over there. Still have the smoke, getting a new board. This is an experimental motor we put together. I cut out the armature, or the fields, and I put in permanent magnets. So it's a DC American Flyer conversion. We now have a way of converting the wired field so that it receives a constant plus or minus DC, and then we can switch the plus or minus on the fields, the brushes, for directional control. So we now will be able to use vintage motors in a DC controlled environment, which is part of the goal, is to use as much of the old gear as we can to facilitate the use of the new gear. So this will not have a big piece of blob there, it will have something nice. But in any case, this streamlines all of that, so that's a good thing. Shortens up the housing as well, and we'll have a motor very much like this one sitting in place with this piece on it. So there you go. It'll be more or less like that, operational, and we will still have to have those two boards, but I have some frames I'm going to be putting in here that will hold the boards and keep everything in order. So onward and upward. We're working on wiring schematics, wire harnesses, refining the components and getting the optimized performance out of sounds and some other things. So we're getting there. This is the plan. This is what we're up to. There's that. Here's this. The brackets are all there. I have some extra plates for the how the tender works, and the trucks will be reused as well. Okay, I just thought I'd share progress. We're making it. It's coming together. This thing will be, I'm hoping, back together within a week or less, and running, and we'll be updating components as we go. We've got things on order, things in design, and this, what we're calling Mule 2, level 1, if you will be pretty operational by the end of November for sure. All right, more later, gang.